All right, we're going to take a look at section 12.3. In 12.2, we focused on measures of central tendency, where by either using mean, median, mode, or mid-range, we were able to come up with a single number that kind of represented the set. Some people say it was the middle value or the average value, but depending on which measure you used, it was a different thing. But it was a single number that told you something about the set. Well, there is something else we need to know when we're looking at data, and your textbook introduces measures of dispersion, which is also the spread of the data. It's how spread out the data is, and tells a little story for you to think about. It says, when you think of Houston, Texas, and Honolulu, Hawaii, do balmy temperatures come to mind? Both cities have a mean temperature of 75. All right, now that is a measure of central tendency. They're using the degree 75 to talk about each of those. However, the mean temperature does not tell the whole story. The temperature in Houston differs seasonally from a low of about 40 degrees in January to a high close to 100 in July and August. By contrast, Honolulu's temperature varies less throughout the year, usually ranging between 60 and 90. Measures of dispersion are used to describe the spread of data items in a data set. Two of the most common measures of dispersion are the range and the standard deviation, and those are going to be discussed in this section. Let's talk first about the range. I'll make this a little larger now. The range is the difference between the highest and the lowest data value in the set. It indicates the total spread of the data. Okay, highest or largest minus lowest or smallest. That's all there is to range. So let's do a few range questions. In the first one, what is the range? What is the spread? Well, the range is the highest, which in this group is 29, minus the lowest, which is 25. It has a spread or a range of 4. Talks about the dispersion. Next one, the range is 22 minus 13, which gives us 9. The third one, even though there is some frequency here, that does not affect the range. The range is 16 minus 6, which is 10. Now, we talked about something called the mid-range in the last section, which was the middle of the range. And it was very different from what we've got here. All right. Now, we're going to lead towards something called standard deviation, but we're going to get there slowly. Let's look at number 4. It says a group of data items and their mean are given. In some problems, the mean is not given and you have to calculate it, so you would have to add them up and divide by the number of items. All right, here's what we're going to look at. Find the deviation from the mean for each data item. Okay, the deviation from the mean is x minus x bar. An item minus the mean. So we know the mean is kind of the middle, it's the average, and we want to know how far each of these items is from it. We're going to take x minus x bar. All right, and they gave us x bar, which is the mean. So for the first one, we have, oh, I'm sorry. Let me get back to you. I touched something with my hand. All right, we have 6 minus 24, which means we have a deviation of negative 18. Sometimes you will get negative and sometimes you will get positive. For the next one, we have 10 minus 24, which is negative 14. We have 14 minus 24, negative 10. We have 24 minus 24, 0. We have 36 minus 24. I know those are kind of hard to read. 12. And we have 54 minus 24, which is 30. So we have filled in the chart with the deviations from the mean. Now they ask us to do something else. They say, what's the sum of the deviations? So the sum is equal to negative 18 plus negative 14 plus negative 10 plus 0 plus 12 plus 30. And since the calculator, I will just do this. Whoops. I got all kinds of things going on here. I'm so sorry. Close. All right. All I want to do is add negative 18 plus negative 14 plus negative 10. Remember to use this one when you're saying negative. Plus 0 plus 12 plus 30. Enter, and I get 0. The sum of the deviations from the mean is 0. All right, that was number 4. Let's look at number 5. We're going to be asked to do something very, very similar. And, all right, I hope I can write small enough on here. My x bar is 294. That's given. So for each one of these, it says deviation from the mean, x minus x bar. So for the first one, I have 234 minus 294, that's the mean, and I get negative 60 for my first deviation. Next one, 261 minus 294, and I get negative 33. Then I have 291 minus 294, negative 3, negative 3. Then I have 294 minus 294, 0. 306 minus 294 gives me 12. And 378 minus 294 is 84. So I fill in my chart, finding the deviations from the mean. And I promise this all is leading somewhere. The sum of the deviations. If the sum is negative 60 plus negative 33 plus negative 3, 0, 12, and 84. And you will get 0 again. Is that a coincidence? Or do we always get 0 for the sum of the deviations from the mean of a group of data? Well, let's try it again. All right, in this one I have one extra step. I have to find the mean, the deviation from the mean for each data item, and then the sum of the deviations. All right, I don't have the mean, so I have to calculate it first. So x bar is 56 plus 106 plus 81 plus 56 plus 131, and I'm going to divide it by 1, 2, 3, 4, 5. N is 5. I can do it like this as long as I use parentheses. So, calculator, parentheses, 56 plus 106 plus 81 plus 56 plus 131. Close the parentheses, divided by 5, and I get a mean. X bar is 86. In the previous problems, they gave that to us. Now I need to complete the table by entering the deviations for the data value. So it's going to be x minus x bar. So 56 minus 86. That gives me negative 30. I have 106 minus 86. That gives me 20. I have 81 minus 86. Negative 5. 56 minus 86, again, negative 30. And 131 minus 86, which is 45. The sum of the deviations is negative 30 plus 20 plus negative 5 is negative 30 plus 45. Let's check it. Negative 30 plus 20 plus negative 5 plus negative 30 plus 45. And I think we're beginning to see that the sum of the deviations is going to be 0. All right, number 7 is just like that. First, I have to find the mean. And if you want to, pause, you do it, and then compare. Oh, so I have 136 plus 142 plus 147 plus 148 plus 152 divided by 5, and that gives me a mean of 145. Okay. Now I need to do the deviations. I have, remember, those are going to be x minus x bar. So for the first one, 136 minus 145 gives me negative 9. 142 minus 145 is negative 3. Whoops, come back here. 147 minus 145 gives me 2. 148 minus 145 is 3. I'm not sure why this is jumping around. And 152 minus 145 is 7. Then finally, I have the sum of the deviations, -9 plus -3 plus 2 plus 3 plus 7. Without my calculator, I know that this makes -12, and I know this makes 12. The sum of the deviations is 0. All right, so several times we have found the deviation from the mean and we added them up, and if we were going to try to find the average of that, the average deviation as a means of measuring dispersion, we can't. This shows that we cannot find the measure of dispersion by finding the mean of the deviations, because this value is always 0. However, a kind of average of the deviations from the mean, called the standard deviation, can be computed. We do so by squaring each deviation. That will make everything positive, except for 0, but we're going to square them. Then when we add them up, they won't equal 0. And then we will take the square root to undo that, and we will get a number that will be called the standard deviation. Now this set of steps describes computing the standard deviation for a set of data. We've done part of it. Find the mean of the data. We've done that. Find the deviation of each data item from the mean. We've done that. But we don't add them up. We do not find the sum yet. We square each of those numbers. So we take the data item minus the mean and we square it. Then we add them up. We divide them by, and I know this is a little weird and it is difficult to explain why. I'm not even going to try in this video. Normally, to find the average of something, the mean of something, you divide by n. Mathematicians have found that when you divide by n, it's off a little bit from what the standard deviation should be, and it has to do with populations versus samples, and so they have found that they get a better measure if they divide by n minus 1, where n is the number of data items. Then, because you squared it, you have to take the square root of that. That number is the standard deviation. The standard deviation of a sample is symbolized by S, while the standard deviation of an entire population is symbolized by sigma, lowercase sigma. Unless otherwise indicated, data sets represent samples, so we will use S for standard deviation. So there's our formula. After we do this using these steps, then I'm going to show you how you can do it using the TI-84 grapher. All right, I've got to give myself plenty of workspace because this process, oh goodness, this process is a little bit lengthy. All right. Step number 1 in finding the standard deviation is to find the mean. And the mean is add them up and divide by the number. So it is 11 plus 12 plus 13 plus 14 plus 15, and I will divide that by 5, and I will get that the mean is 13. Step 2. And I am getting these steps from this right here. Find the deviation. All right. So the deviations, I have 11 minus 13 is -2. I have 12 minus 13 is negative 1. I have 13 minus 13, which is 0. I have 14 minus 13. I'm subtracting the mean from each one of these, which is 1. And I have 15 minus 13, which is 2. Now we know that the sum of the deviations is going to be 0. So what we're going to do in step 3, and I'll put it right over here, it'll make it easier, I'm going to take the deviations and I'm going to square them. So I will have negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. All right, step number 4. I'm going to sum the deviation squared. Now, what that looks like, formula-wise, it is the sum of x minus x bar squared. It's the sum of the squares. So in my problem, it's 4 plus 1 plus 0 plus 1 plus 4, which gives me 10. Step number 5, and let's go back up. Divide the sum in step 4 by n minus 1. Divide by n minus 1. So it is the sum of the deviations from the mean squared divided by n minus 1. So it is 10 divided by, there were 5 items, so that's minus 1. That is 10 divided by 4, which is 2.5. Now I'm not quite finished. I have one more step. Step number 6 is I'm going to take the square root. So I'm going to take the square root of the sum of the squares of the deviations divided by n minus 1. So in this problem, I'm going to take the square root of 2.5, which gives me 1.58. Because this was just a sample, I'm going to say S, the standard deviation, is 1.58. And that's a little bit like saying the average difference between each item and the mean is 1.58. All right, now I want to show you how to get that same number, but I'm going to use the calculator. All right, I've grabbed my calculator. The steps that I need are right up here. Okay, back to the calculator. So it says hit stat, and you have that list in your notes, in the handout, stat. This time I'm choosing edit. You come up with some lists. In this list, I'm going to put in L1, I'm going to put in my data. My data was 11, enter, 12, enter, 13, enter, 14, enter, 15, enter. So I went to Stat, Edit, and I listed in L1 all of the items. I hit the Stat button again, and remember this is like a recipe and you've got this in your handout. This time you go right, away from Edit, toward Calc. And you are going to do one variable statistics. And that is already the default. It is number 1, so all you have to do is press enter. So my old calculator, it didn't do this, but I'm going to, our information is in L1, so I will go through here, go down to calculate, and I have a lot of information. First of all, it tells me that my mean, well, you know what, I'm going to grab this and put it right down here. But you know it probably went somewhere else. Where did it go? There it is. All right. It says my mean is 13. Was that the mean that we got? Yes, it's right there. The sum of the x's was 65. I didn't need to know that. It gave me the sum of the squares. This is it. We call it S. They call it S with a little x like that. It is the standard deviation of the set of x's. Now this one would be, it is different, has to do with population. We're not going to use it. You're going to choose SX. And do you see, there's that answer, and there it is on the calculator. Now, although I might ask you to do these steps for me sometime, we're going to use the calculator for the rest of our standard deviation questions. All right, so here we go. Hopefully you'll feel pretty good about this process by the time you're through with several homework problems. Number 9, I am going to clear my home screen. I'm going to go to Stat, choose Edit, which is the first one. It has values in the L1. I can type over them. 6, enter, 6, enter, 7, enter, 7, enter, 8, enter, 8, enter. All right, this time I have 6 values in there. I want to get the standard deviation. Now, if I did it the long way, I would have to calculate the mean, get the deviations from the mean, square those numbers, add them up, divide by n minus 1, and then take the square root. But now, all I have to do is hit Stat again, go right to Calc. I want the one variable statistics. I am using L1, so you can just go down till Calculate is highlighted, hit Enter. The standard deviation, and it says round to 2 decimal places. I'm going to grab that, and it will go somewhere. Does not seem to want to go where I want it to. This will be just fine. The standard deviation is this right here, and we're going to round to 2 places. So this is, sorry about that little crosshair there. It is 0.89. That's my standard deviation. So the mean of the deviations, each number as a group is approximately, the average dispersion is 0.89. All right, let's do it again. with number 10. Get just a little more room. Calculator. Clear that off. Go to Stat. Edit. Type my numbers in. I have 6, enter, 6, enter, 6, enter. Then I have an 8, enter, 10, enter, 10, enter, 10, enter. I hit Stat again. I go right to Calc. I choose one variable statistics. That's what I want. I can go down. You could use Enter to go down. And there we go. Nope, too far. My standard deviation for this sample is 2. Number 11. Sometimes when I try to get space, I just get a line. All right. Practice this again. I cleared off my home screen. I think that's always a good idea. Stat. Edit. Now, if you ever wanted to, you can delete values from here. For instance, say you had a set of data that only had 4 values and you already had 10 in there, you would have to delete some of them. But anyway, all right, 18, enter, 14, enter, 18, enter, 14, enter, 18, enter, 14, enter, 18, enter, 14, enter. I hope I got that right. Stat, this is so quick. Go right to Calc, one variable, go down to Calculate, and Enter. All right, I will grab that. Move it up just a little bit, and the standard deviation for my sample rounded to 2 decimal places will be 2.14. That 8 causes me to round that up to a 4. Now our very last question, I think, really helps us with a lot of understanding. We have 3 sets of data. We're going to calculate the mean, the range, and the standard deviation for each one of them. Then we're going to do some comparisons. All right, so I've got a good bit of work to do. I'm going to let the calculator do the mean and the standard deviation for each one. I can do the range. Remember that the range is the max minus the min. So for the first one, it's 51 minus 39, which is 12. For the second one, it is 51 minus 39, which is 12. And for the third one, it is 51 minus 39, which is 12. So for all of these, the max and the min were the same, so the range was the same. They are different sets of numbers, so perhaps that's going to affect things. Remember, dispersion can be described by the range or by the standard deviation. And the mean, of course, is that one number that describes the central tendency. All right, let's take the first group. This is for A. Stat, choose Edit, and I'm going to delete some of these. Don't use Clear, use Delete. And don't do it while you're on L1. Make sure you're down in here. All right, so 39, enter. 41, enter. I'm using this set of data right here. 38, 39, oh wait. No, 39, 41, 43, 45, 47, 49, 51. And I have an error. This was supposed to be 45. So, do I have them all? 39, 41, 43, 45. They did them by counting by twos. All right, I have it all. So stat, calc, one variable, all right, the mean for this set is 45, and the standard deviation, I need it back, the standard deviation rounded to 2 places is right here. It's 4.32, and I'm going to grab this, and I'm sure it went somewhere. There it is. This is for a okay. Now let's look at set B. Stat, edit. All right, this data, they're the same number of items, so 39 is there. Now I can type it again. 39, enter. 40, 40, oops, 41, enter. 45, enter. 49, enter. 50, enter. 51, enter. Let me check them. All right, 51, 50, 49, 45, 41, 40, and 39. Okay. Stat, calc, 1. The mean is still 45, but the standard deviation has changed. It's 5.07. All right, I'm going to pull it down. 5.07. 5.07. Mean was 45. Okay, I guess it wants to stay here. This is for set B. All right, set C. Stat, edit. I have 39, enter, 39, enter, 39, enter, 45, enter, 51, enter, 51, enter, 51, enter. All right, stat, calc, one variable. All right, I get the same mean, but my standard deviation is 6. Let's get that back. All right, they all had 7 data values. They all had means of 45, but their standard deviations were very different. All right. The last couple of questions here say, in which of the following ways are the samples alike? The means are alike, the range is alike, and that's it. So we'll choose mean and range. In which way are they different? In its standard deviation. Now, what does that mean? That means that sample A, the values do not have as much dispersion. They are not as far apart as sample C. Sample C, the items, there is more spread among the items. All right? So practice doing standard deviation by the process at least once, and then practice using it with your calculator.